Somewhere out there, right now, on a world we have never seen, orbiting a star we may never have cataloged, something might be thinking. Not imagining, not guessing, but actually thinking in a way that is utterly alien to anything a human brain has ever produced. And if that is true, then one of the deepest assumptions buried in our search for extraterrestrial intelligence may be wrong. We have spent more than 60 years scanning the sky for radio signals, for laser pulses, and for the electromagnetic fingerprints of technology, all built on the quiet hope that somewhere out there is a mind enough like ours that it would think to send a message, in a form we could recognize, using physics we already understand. But what if that hope is itself a kind of parochialism, a very human failure of imagination? What if the civilizations most likely to exist are not the ones broadcasting on frequencies we monitor, but ones so far beyond our conceptual reach that we would not recognize their presence even if it were sitting right in front of us? This is a strange thought to sit with because it does not just ask whether we are alone. It asks whether our entire framework for asking the question is too small. Let's begin with a number, because numbers have a way of making the abstract feel real. Our sun is one of roughly 200 billion stars in the Milky Way. The Milky Way is one of somewhere between 1 and 2 trillion galaxies within the observable universe. Multiply those together and you get a number of stars so large that writing it out feels almost absurd, something on the order of 10 to the 23rd power. That is more stars than there are grains of sand on every beach and desert on Earth combined, many times over. And in recent decades, we have learned something that our grandparents did not know. Planets are not rare. They are the rule, not the exception. Nearly every star we have studied closely seems to host a retinue of worlds, and a meaningful fraction of those worlds sit in the so-called habitable zone, where liquid water could, in principle, pool on a surface. Run the numbers conservatively, and you arrive at billions of potentially habitable planets in our galaxy alone. This is the first half of what is sometimes called the Fermi Paradox, named for the physicist Enrico Fermi, who is said to have looked around at his colleagues over lunch one day at Los Alamos and simply asked, "Where is everybody?" Given how vast and how old the universe is, given how commonplace the raw ingredients for life appear to be, the silence should be strange. And it is. There are broadly two families of answers to Fermi's question. The first family says that life, and especially intelligent technological life, is rare. Perhaps rarer than we like to admit. Perhaps the jump from simple chemistry to self-replicating molecules is a leap that almost never succeeds. Perhaps the jump from single-celled organisms to complex multicellular life is an evolutionary bottleneck so narrow that Earth is a fluke. Perhaps the jump from complex life to intelligence capable of building radio telescopes is rarer still. This is often called the Great Filter. The idea that somewhere along the road from lifeless chemistry to a civilization capable of contacting the stars, there is a barrier that very few, if any, paths manage to cross. If the filter lies behind us, in our own deep past, then we are something remarkable. A fluke that beat the odds, and the silence of the universe is simply the sound of failure elsewhere. But if the filter lies ahead of us, that is a far more unsettling thought, because it would mean that civilizations like ours tend to arise and then tend not to survive their own adolescence. The second family of answers takes a different path entirely. It accepts that intelligent life might be common, even abundant, and asks instead whether we would even notice it if it were here. And this is where the story gets genuinely strange, because it forces us to confront just how narrow our search has been. When the astronomer Frank Drake pointed a radio telescope at the sky in 1960 in what became known as Project Ozma, he was making a reasonable bet given the technology of his time. Radio waves travel at the speed of light, they are cheap to produce, and they pass through the interstellar medium with relatively little absorption. It made sense in 1960 to listen for radio. But ask yourself a question: how long in the history of any civilization does the radio window actually stay open? Humans have been broadcasting into space for roughly a century, and already we are moving away from powerful, leaky broadcasts toward tightly beamed, low-power encrypted digital signals, toward fiber optic cables buried underground, toward technologies that simply do not spill electromagnetic noise into the cosmos the way old analog television and radio once did. If an alien civilization has existed for even a few thousand years past the point where we currently are, let alone a few million, the odds that they are still broadcasting the kind of leaky radio signal we know how to detect could be vanishingly small. We may be listening for smoke signals in an age of encrypted fiber optics and mistaking the silence for absence. But let's go further, because the deeper problem is not just about which channel a civilization uses to communicate. The deeper problem is about what kind of physics an advanced civilization might have access to, and whether human science, for all its genuine power, sits anywhere close to the edge of what is possible to know and to do. Think about where we stand today. We have general relativity, a staggeringly successful theory of gravity, space, and time, published by Einstein in 1915. We have quantum mechanics, an equally successful theory of the very small, developed across the early 20th century. And we have a nagging, uncomfortable truth sitting underneath both of them: they do not fit together. When physicists try to describe gravity at the quantum scale, the mathematics breaks down into meaningless infinities. String theory, the framework I have spent much of my career working on, is one attempt to heal that rift by proposing that the fundamental constituents of reality are not point particles but tiny vibrating strands of energy, whose different vibrational patterns give rise to all the particles and forces we observe. It is an elegant idea. It may even be correct. But decades after its inception, we still do not have direct experimental confirmation of it. We are, in a very real sense, still building the instruction manual for the universe, and we are missing pages. Now stretch that same effort not across 1 century of human science, but across 10,000 years, or 100,000, or 1,000,000 years of an alien civilization's uninterrupted development. What would their instruction manual look like? It is worth pausing on just how young our physics actually is. Isaac Newton wrote down the laws of motion and universal gravitation a little over 300 years ago. Before that, for the overwhelming majority of human history, we had no real physics at all, only observation, myth, and guesswork. 300 years is a blink. It is nothing on a cosmic timescale. And yet in that blink, we went from not understanding why apples fall, to splitting the atom, to detecting gravitational waves rippling across the fabric of space-time from black holes colliding over 1 billion light years away, to landing spacecraft on comets. If we compress that entire trajectory and then imagine a civilization that has simply had more time, not infinite time, just more, the outcome is not a civilization that is a little bit ahead of us. It is very plausibly a civilization operating in a regime of physics we do not yet have words for. This brings us to an idea proposed by the Russian astrophysicist Nikolai Kardashev in 1964, a way of classifying civilizations not by their culture or their biology, but by their energy consumption, because energy is, in a sense, the universal currency of capability. A Type 1 civilization in Kardashev's scheme harnesses roughly all the energy available on its home planet, something on the order of what our sun delivers to Earth. A Type 2 civilization harnesses the entire energy output of its star, perhaps by building a structure that encloses it, an idea popularized as a Dyson sphere after the physicist Freeman Dyson. A Type 3 civilization harnesses the energy of its entire galaxy. Here is the sobering part. By most estimates, humanity today sits at something like Type 0.7%. We are not even a full Type 1 civilization yet. We still burn ancient sunlight stored in fossilized carbon to power much of our world. Now, imagine a civilization that crossed the Type 1 threshold 100,000 years ago. Imagine one that reached Type 2 1,000,000 years ago. The gap between where we stand and where such a civilization might stand is not measured in decades of technological progress, the way we might compare our era to the Victorian era. It is measured in something closer to the gap between a Victorian engineer and an ant colony. Except that comparison is almost certainly still too generous to us, because it assumes the alien civilization is doing recognizably similar things, just more of them, when the truth might be that they are doing entirely different things, built on physical principles we have not discovered yet. Here is where I want to bring in a thought experiment that has stayed with me for years, one that reframes the entire question. Imagine for a moment an ant colony living at the edge of a highway. The ants are not stupid. Within their own frame of reference, they are remarkably sophisticated. They build complex tunnel networks. They farm fungus. They wage coordinated wars. They communicate through pheromone trails with real information content. But no ant, no matter how industrious, will ever comprehend what a highway is for. It will never grasp the concept of a commuter, a traffic signal, an internal combustion engine, a supply chain, or a Tuesday. Not because ants are inferior in some moral sense, but because the highway was built by minds operating in a completely different explanatory space, addressing problems and concepts that simply do not exist within the ant's cognitive world. The ants can feel the vibration of passing trucks. They might even adapt to it. But the meaning of the highway, its purpose, its physics, its economics is permanently outside their reach. Now, I am not saying humans are ants. We have something no ant has: abstract mathematics, the scientific method, the ability to model and question and revise our understanding of reality itself. That capacity is genuinely remarkable, and it is why I don't think the comparison is a totally fair one. But I raise the ant colony not to insult human intelligence, rather to illustrate a structural point that has nothing to do with how smart you are and everything to do with the gap in accumulated understanding between two minds. Even a very intelligent ant is still an ant, still bound by the sensory and conceptual toolkit evolution gave it. And if a civilization has had 1,000,000 extra years to develop concepts, tools, and physics we do not yet have the vocabulary for, our own formidable human intelligence might not save us from occupying the ant's position in that particular relationship. Let's take this seriously as physics, not just as metaphor, because there are real current gaps in our understanding of the universe that a sufficiently advanced civilization might have already closed. Consider dark matter, first inferred by Fritz Zwicky in the 1930s from the way galaxies rotate faster than the visible matter within them should allow, and later confirmed through countless independent lines of evidence. We now believe dark matter makes up roughly 85% of all the matter in the universe, and we still do not know what it is. Not really. We have candidate particles, we have elaborate detectors buried deep underground to shield them from cosmic ray noise, and after decades of searching, we have not made a confirmed direct detection. An advanced civilization might not merely have detected dark matter. They might have learned to manipulate it, to harness it the way we harness electromagnetism. Consider dark energy, the mysterious force, discovered only in 1998, that appears to be accelerating the expansion of the universe itself. We have a name for it, we have a rough measurement of its effect, and beyond that we are largely guessing at its nature. Consider quantum entanglement, a phenomenon so strange that Einstein himself distrusted it, dismissively calling it spooky action at a distance in which two particles can remain correlated across vast distances in a way that seems to defy our ordinary intuitions about locality. We can observe entanglement, we can even use it in emerging quantum computing and quantum cryptography systems, but our understanding of what it actually means for the underlying nature of reality remains genuinely unsettled. A live and contentious debate among physicists. Every one of these is a frontier where our current physics runs out, not because the universe is uncooperative, but because we simply have not had enough time, enough tools, and enough accumulated insight to see past the horizon. A civilization with a sufficient head start might not be waiting at these same frontiers. They might have already walked through them and kept going into a landscape of physical law we cannot yet even formulate the right questions about. This is, I think, the heart of what it would mean for an alien civilization to be beyond our understanding, not simply that they have bigger spaceships or brighter lasers, but that they may operate with a working physics substantially more complete than our own. The way our physics is more complete than that of a civilization from 1,000 years ago that believed comets were divine omens. And if that gap is real, then some of our most confident assumptions about how contact should look may simply not apply. We assume a civilization wanting to be found would use electromagnetic radiation because that is the fastest and most efficient method of communication available to us. But if a civilization has mastered physics beyond general relativity, They may have access to methods of transmitting information that do not rely on electromagnetic waves at all. Methods built on principles that, from our vantage point, might look indistinguishable from nothing. There's a phrase, often attributed to the science fiction writer Arthur C. Clarke, that any sufficiently advanced technology is indistinguishable from magic. I'd push that idea one step further and suggest that any sufficiently advanced civilization's ordinary activity might be indistinguishable from the background noise of nature itself. We might be looking directly at the evidence of extraterrestrial intelligence and simply filing it under natural phenomena, because we have no framework that tells us otherwise. Consider, for instance, the strange behavior of the star known as KIC 8,462,852, more commonly called Tabby's star, or Boyajian star, after the astronomer who led its study. Data from the Kepler Space Telescope showed this star dimming in irregular, unpredictable patterns, at times by as much as 20%, far beyond what a transiting planet could produce. For a brief period, some scientists seriously floated the hypothesis that we might be observing the construction of a Dyson swarm, a partial megastructure built by an advanced civilization to harvest starlight. The mainstream explanation that eventually gained the most support involves uneven clouds of circumstellar dust, and that is very likely the correct mundane answer. But notice what happened in the scientific process itself. For a moment, credible scientists had to seriously entertain the alien hypothesis, precisely because the natural explanations available to them at that time did not neatly fit the data. That episode is a small, humbling reminder that the line between an unexplained natural phenomenon and an unrecognized artifact of intelligence is not always as sharp as we would like it to be, and our default assumption tends to fall on the side of nature, in part because it is the more comfortable, more parsimonious answer, and often that assumption is correct. But it will not always be correct, and we may not have the tools to tell the difference even when it isn't. Let's push the thought experiment even further into territory that brushes up against the genuinely speculative edge of theoretical physics, the kind of territory where I have to be honest with you that we are reasoning by extrapolation rather than by evidence. String theory, in its most mathematically consistent form, requires more than the 3 spatial dimensions we experience directly, often 10 or 11 dimensions total, with the extra ones curled up at scales far too small for us to currently probe. If those extra dimensions are real, and that remains a genuinely open question, then the observable universe we inhabit may be something like a slice, a 3-dimensional membrane, floating within a higher dimensional space that we cannot perceive with our senses, in the same way a 2-dimensional shadow on a wall cannot perceive the 3-dimensional object casting it. Now entertain a purely speculative possibility. What if a sufficiently advanced civilization learned to interact with those extra dimensions, not merely to model them mathematically the way we do, but to actually use them, to store information in them, to travel through them, to communicate across them? From within our 3-dimensional slice of reality, such activity might not look like a spaceship arriving in our sky. It might not look like anything at all because it would not be happening within the dimensions our instruments are built to measure. I want to be careful here because this is speculation built on speculation. String theory itself remains unconfirmed, and I am not asserting any of this as established fact. But the exercise is valuable precisely because it illustrates how narrow our search for extraterrestrial intelligence has been. We have been listening for signals traveling through the 3 dimensions and 1 time dimension we know how to detect, using a very small slice of the electromagnetic spectrum. If the true landscape of physical possibility is even a fraction larger than that, and there are real theoretical reasons to think it might be, then our search has been the equivalent of scanning a single radio frequency in a single room for evidence of a civilization that might be communicating through the entire building. There's another angle worth sitting with, one that has less to do with exotic physics and more to do with something almost philosophical, the sheer strangeness of trying to imagine a mind built on a substrate wildly different from our own. Human cognition evolved for extremely specific parochial purposes: to track predators on the African savanna, to navigate social hierarchies within small kin groups, to find food, to avoid becoming food. Every metaphor we use to think about the universe, every intuition we bring to a physics problem is quietly shaped by that evolutionary inheritance. When we imagine an alien mind, we tend to imagine something like a more advanced version of ourselves, a scientist, an explorer, perhaps a conqueror, because those are the categories our own history has handed us. But there is no law of physics that says an intelligent, technological civilization needs a mind that resembles ours in any way at all. It might not experience anything we would recognize as curiosity or ambition or even individuality in the way we understand it. It might be a distributed intelligence spread across an entire planetary ecosystem with no single locus we would recognize as a person. It might operate on timescales so slow or so fast relative to our own biological rhythms that we would fail to recognize its behavior as behavior at all, in the same way a mayfly living for a single day would never perceive the slow creep of continental drift as motion, even though it is happening all around it all the time. The philosopher Thomas Nagel wrote a now famous essay asking what it is like to be a bat, arguing that even a mind as biologically similar to ours as a bat's, sharing the same planet, the same evolutionary history, the same basic neurochemistry, might have a subjective experience so alien to us that we cannot truly imagine it from the inside, only from the outside as an observer. If that gap exists between us and a bat, a fellow mammal, then the gap between us and a mind that evolved under a different star, under different physical constraints, over a different span of time, could be immeasurably larger. We would not just be unable to speak their language, we might be unable to recognize that a language was being spoken at all. So where does this leave us? Not, I think, in despair, and not in a place that should discourage the search. If anything, it should expand it. The traditional search for extraterrestrial intelligence, listening for deliberate radio signals aimed at us, remains worthwhile because it costs relatively little, and the payoff, if it succeeded, would be the single most important discovery in the history of our species. But alongside it, a newer and stranger kind of search has begun to take shape, one that looks not for messages, but for what scientists call technosignatures, the unintentional byproducts of advanced technology. The heat signature of a Dyson swarm absorbing a star's energy, chemical signatures in a distant planet's atmosphere that could not plausibly arise from geology or biology alone, industrial pollutants. For instance, the way our own atmosphere now carries the chemical fingerprint of human industry, visible in principle to any sufficiently sensitive observer looking at Earth from many light years away. There are unusual patterns of stellar dimming that resist every natural explanation we can construct. This kind of search does not require an alien civilization to want to be found. It only requires them to exist and to do things the way any technological civilization inevitably leaves traces of its own activity on its environment, whether it intends to or not. And there is something quietly humbling, even beautiful, in reframing the search this way, because it asks us to hold two ideas at once without letting either one collapse into the other. The first is a kind of epistemic humility, an honest acknowledgement that our physics, however extraordinary its accomplishments, is very likely still a rough draft, one chapter in a much longer book we have not finished writing, and that our failure to detect other minds in the universe may say as much about the limits of our instruments and our imagination as it does about the actual prevalence of life. The second is a kind of stubborn optimism, the recognition that every single expansion of human understanding across history, from the telescope to the electron microscope to the gravitational wave detector, has revealed a universe stranger, richer, and more populated with structure than the one that came before it. There is no particular reason to think that trend stops here, at the edge of what we currently know how to detect. Perhaps the truest answer to Fermi's question is not that we are alone, and not that everyone else has gone silent, but that we have been listening for the wrong kind of silence. Perhaps the universe is not empty. Perhaps it is simply speaking in a language built from physics we have not yet learned to read, using channels we have not yet learned to open, on timescales we have not yet learned to perceive. The ant at the edge of the highway does not conclude that the highway does not exist. It simply lacks the concepts to understand what is rushing past it. We may be in a remarkably similar position, standing at the edge of something vast, feeling only the faint vibration of its passing, mistaking the tremor for background noise when it might, in fact, be the sound of an entire civilization or 1,000 civilizations going about their business in a universe far stranger and far more populated than we have yet allowed ourselves to imagine. And if that's true, then the next great leap in this search may not come from a bigger telescope or a more sensitive antenna, though we will need those too. It may come from the humility to admit that the universe was never obligated to make itself understandable to us, and the patience to keep expanding what we are capable of understanding, one discovery, one theory, one uncomfortable revision at a time, until the day the silence finally breaks, or until we finally build the instruments and the minds capable of hearing what has been there quietly all along.